Hey guys, how are you doing? How's your day going? And we're just starting. How's your night? Hope you had or having an amazing and a beautiful day today. Was you on everything Python? Obviously, a lot of you are like wondering when are we going to start getting into the practical part of Python. This video is going to actually start opening your eyes little by little. So this video is going to be split into two parts. Initially, I was saying how I was going to split because we do have it's going to be quite a handful. We're covering common packages and models. Obviously, we're not going to do every single models, but if you want me to make it a whole series, you can let me know. Just leave in the comments what models or package you want me to do a video on, and I'll do that and arrange everything into a new playlist so you can see it there. But I have a list of some packages and models I want you to do. So initially I was going to split them, but I said that let me just combine it. Let this just be an intro. Then if you want it in more detailed, you can let me know. I'll make a longer video, or you can check my blog. The link is in the description where I go more in depth in that. Once again, if there's any model or package you want me to cover, let me know in the description below. We have covered models so you have an idea of how to import, how to create your own model. We've also worked with installation packages like pip and grss. Pip are going to be using in this video. But yeah, without further ado, let's get into the first one that almost everybody uses, but for some reason is not included by default in Python's package, whatever they call it, and that they're inbuilt models, and that is the request models. Python's request library is a powerful tool that allows developers to send HTTP requests in a straightforward and user-friendly way. So since it's not installed, you're going to have to manually install that using pip. So just open our terminal. We're going to do pip install request. Always make sure that you're connected to the internet before you do this, even though you're going to get an error. So we're going to do pip install request with an S. Okay. I already have it installed, so it should tell me requirements already satisfied. So once it's installed, we're going to go back to our Python file. Let me just close this tab up and close this one up. And we're going to import it. So remember I told you there are different ways to import, but here we're just going to do it straight up import request. Okay, now the first thing, so when you're working with HTTP generally outside of Python, there are certain types of requests that you expect or that you are planning on getting. So you have the get request, the post request, which are like two of the main important ones. There's also put, but we're going to be working with the get request now. So when you are working with a get request, as name implies, you want to get something from that URL. So let's just create a variable called response, because it's a response we're trying to get. And we're going to say request dot get, and within it we're now going to pass in the URL we want to use. So let's just use GitHub's or URL, so that is HTTPS. I'm sure you guys already know the difference between HTTP and HTTPS. HTTPS is more secure. If you want me to go into a video where I'm explaining all this more further, you can let me know. And once you get this, we want to now, let's just print out something. Let's get the status code. So you could get like a 200 as the code, which is like a good thing. You could get 404 that it's not found. So let's just do print. I don't know why I did that. Response dot status underscore code. I'm just gonna run it. Okay. So 200, that means we successfully accessed the GitHub's database, I guess. Then now when you are working with content, that means you can just access like certain content in different formats. So let's do, for example, we'll still leave the response. So let's get it in a text format. We'll just say, well, let's just print it directly, right? Let's just print it directly. We'll say print response dot text. So a bunch of things were given to us. So as of now, we're just going to ignore it. But yeah, you can also pass it in different other formats. But yeah, what else do you want to cover in this request? Okay, so we have something called headers. They are used to access the response headers, which contain metadata about a response. If you have worked with HTML, I'm sure you'll be familiar with what metadata are. So if you want to do this, you can just like within the response, you just say, let should we just do it within the print? So we'll just say response dot headers. And we're just going to have our square brace. So within it, we're going to just pass content type. So we want to get what type of just content type. Just bring that. So just tell us like what format. So there are still so many other ones on the blog. I have a more detailed breakdown of everything. But yeah, okay. So now we're going to touch on something called polars. So it's another model. If you have worked or dabbled in data science or data analysis using Python, you may have come across pandas. So think of polars as another version of pandas. It may be an updated version, it may not be. It's left for you to decide. So it's a data analysis manipulation library similar to NumPy, Pandas, PySpark, and Dask. So if you want me to cover all those ones, I think I already have videos on NumPy and Pandas, but those other ones, PySpark and Dask, if you want me to cover them, you can let me know. Polars is a high-performance data frame library designed to provide fast and efficient data processing capabilities inspired by pandas, but allows you to work with large data sets that might not fit into your system's memory. So Polars combines the flexibility and user friendliness of Python with the speed and scalability of Rust, which is the language it was developed in. So if you want to do it, since it doesn't come defaultly by default into this, you have to pip install it. So you just do pip install Polars with an S. Okay. And after you've done that, obviously the next thing you're going to do is import it. So we're going to import Polars as let's import it as peel. And now Polars allows you to interact with the broader Python ecosystem and external data sources. For example, if you want to convert Polars data frames to Pandas data frames and NumPy arrays, then you have to, there's a specific type of installation you're going to do. You're going to do pip install, but instead of just installing Polars, you're going to have this inverted comma, and within it, you're now going to pass Polars, and you have your square brace, and within that you're now going to either pass or so it installs everything, or you can specify that you want it for NumPy, Pandas, and you can keep listing as much as you want. But if you're not working on, if you like, you want to have your options without open, you can just simply just pass all. So data frames, okay. So the data structure used in pandas as sorry, not pandas, in polars is data frames, which is also the same one used in pandas. A data frame is a two-dimensional data structure composed of rows and columns. The columns of a data frames are made up of series, which are one-dimensionally labeled arrays. So to create a pandas data frame, a polars data frame, sorry, we will first import NumPy. We'll still need Pandas, so let's just import NumPy as np. Okay, so now we're going to set the number of rows we want. So we're going to say number of rows. Let's just use 5,000, and then we're going to say the range is going to be np dot random. So we don't have like specific values you want. Then We'll now set what our seed is going to be. So let's just say seed is going to be equals to 7. So now let's start creating the data we want. Buildings underscore data. Okay, so I've just defined our columns and how the value should be, like the type of value we want for each of those individual columns. Then now that we have our data type down, let's just um so just change it into the appropriate what do you call it, data type that we want to use, and now we can print it. So this is going to give us a table of our new data. Okay, so obviously we're not seeing everything, we're just seeing the first, I think, first five and the last five, but you get an idea of how it works. So now we want to explore the data because we don't just want to generate data, I want to explore it. So if you want to explore, there are different code you can use to explore. For example, if you want to get, sorry, the individual data type of each column, you just do, let's just come to print here, buildings dot schema. So it will list what the column name is and then it will print out the data type. If you want to get just kind of like the way pandas works, if you want to get the first five, you just do buildings dot head. You can also specify the numbers you want if you don't just want it to be the first five, but by default, if you don't pass anything, it will be the first five values. What else? If so, we also had this in pandas buildings dot describe. It will give you like details about just general details. Let's just say, so you have things like minimum, maximum, stuff like that. It's going to be a table too, I think. It should be, yeah. So you have, okay, the statistics, then what each of the column is. So the total values that know the mean, the standard deviation, the minimum value, the 25th percentile, 50th percentile, 7th percentile, and the max value. Yeah. Then gosh, I think my laptop's about to go off, so we'll just brush through polars, and once I plug it, we'll resume. So in polars, you have something called context and expression. Context and expression are the core components of polars unique data transformation syntax. So expression includes mathematical operations, aggregations, comparison, string manipulation, etc. While context refers to the specific environment or situation in which an expression is evaluated. So it has three main contexts that is as this: the selection, which is used for selecting columns from a data frame; filtering, which is used for reducing the data frame size by extracting rows that meet specified condition using like conditionals; group bioaggregation for computing summary statistics with subgroups of the data. So you can think of context as a verb and expression as the noun. So context determine how the expressions are evaluated and executed. Let's take, for example, the select method in polars. So let's say we have our buildings here. So just keep printing it. So we can say, why is not buildings dot select. Then you now put the name of the column you want to select for. So we just have square feet. Just save that and run it. So it's just going to return a series of that square feet table there. So you can pass any single one you want. You could also, another way to carry out this exact same function is to do buildings dot select. Then you're now going to use pl dot call. So you want to use polar to select a specific column, and then again, once again, you just pass the column name you want to select. It's going to be the exact same thing. So you can use whichever one your heart desires. If you want it sorted, you can do select the column you want to sort from, then pass the Python sort function, and then we'll just it's going to just sort it. You can set it to sort in reverse. Then if you want to select ones that occur at specific time, let's say for the year you want ones that occur after 2015, you use the filter function. So you say buildings dot filter, and then you're now going to select which column it is you want to filter. So pl dot column dot year, and you now pass in your condition a year that is greater than 2015. You can also pass in other actions like getting the mean. You just do dot mean. Okay, it's supposed to be select, not filter. Sorry. Okay, so you can keep on using it like that. There's also something in Polars called the lazy API, which allows you to specify a sequence of operations without immediately running them. They are saved as computational graphs. So when you want to work with lazy frames, what you just do is, let me just clean this up. So you have lazy underscore buildings, and it's going to be equals to building. So you just call the data frame dot lazy. So if we're now to print, this is what we're going to have. So I will down the line, I will show you how to use it. But let me just plug in my system and we'll come back to do Patlib. Alright, so now we're going to be touching on the Patlib library. So this library helps you handle files, directories, files in your system, whether it's creating, moving, any single thing like that. So first thing you're going to do, so this is already installed in your system. So it's a built-in model. So all you have to do is just import it. So from patlib, we're going to import path, that is the capital letter P. Okay. So there are multiple actions you can carry out using patlib. First thing is when you want to create a path object. Now this creating path object is not going to create a new file. What you just do is you point to the location. Let's say for example now I want to point to this current directory where we are, unless I want to point to a file that doesn't exist. Let's say praise.py. Now that is the path object I'm going to create. So I can now use that and now check if that path exists. If it exists, I will now do certain things. If it doesn't exist, I'll now do certain things. So you could also point to a path that does exist, but creating a I feel like a lot of people confuse this. Creating a path object doesn't mean creating a directory file. So to do this, we're going to say path is going to be equals to path, and we're just going to point to the directory where we have the file. So we'll just use this our current directory, and let's just point. Let's use a file that doesn't exist yet. Let's use d.py. Okay. Now we can now check if that path exists. So to do so, you can just say if path dot exist, you now carry out an action. So maybe we'll just print found. Okay. Else we just print No directory. Okay, so let's save that and let's run it. So no directory. So had it been now we were to point to a file that does actually exist, let's use this text file. So that is text.txt. It found the directory. So even though that path doesn't exist, the path object will be created. It's just kind of like a pointer. So next now, if you now want to create a directory, alright, so we'll just say from what am I saying? From path lib import path. Alright, so we're first going to give the directory we want a name. So just say path to directory is going to be equals to, we'll create a path object, a pointer, and we want the directory name to be called. Next, we're going to now carry out an action on this path.dir variable we just created, which is the make dir that anybody who uses a terminal should be familiar with. So we're just going to pass some true argument, then exist. Okay, so that if the directory already exists, it's not going to clash or raise any error. So we save that and we run it. These are our path directory. Next thing, if you want to iterate over files in a directory, so let's iterate over the Python directory that we're currently in. So we're just going to say let's set path is going to be equals to, which directory should we use? This is our ven directory. VENV. Okay, so we're going to say for file in path dot iter dir. You can now carry out what action you want to do with the file. In this case, let's just print it. So it's not going to print the content, it's just going to print the file name. And if there's like a directory with a file inside, it will print like the directory like this. So it print, yeah. Okay. Next thing now, if you now actually do want to read the file, you first obviously create they just do the path again is equals to path. Let's use text. Do I have any content in that file? I don't think so. Then we'll just say content is going to be equals to path dot read underscore text, and then you can now print it out. Alright. Then to add a new value to it, we'll just not add. I think if you're writing, it's going to overwrite. So just say path dot write underscore text, and we'll just pass in the text we want to write here. Okay, this is almost like functions like the file input output operator. If you want to move or rename a file, so the way you usually do this is if you want to, okay, let's create the new part first. So Our new part is going to be equals to part dot write with underscore name. Okay, so um let's give, okay, let's just use new.txt. So if we want to just rename it, what we'll just do is just the part we want to rename, part dot rename, and the new part that you want to use to rename it. So yeah, so if you want to delete a file, once again we just create our part. What's the file I want to delete? Text.txt. We just say part dot on link, and file is deleted. And one last thing, if you want to get information about a file, we'll just use um a.py. So if you want to get information about it, we're just going to print. If you want to get the file size, you just say part dot start dot. So now here's where you have multiple ones you can use. The full list to be on the blog, but we'll just do three. So we have st underscore size. The size are in bytes like the pop-up should. So we'll, let me maybe put a text so you know this one is for size. Then last modified. Didn't spell that well, but just ignore it. So it's going to be part dot start dot st underscore m time. And if you want to get when the file was created, oh shit, I didn't even realize I did this. Pardon me. Okay, created. I'm not spelling anything right. It's going to be part dot start um st, instead of m time, is going to be c time. Okay, save that and run it. So yeah, let's go into another model. This one is going to be a bit bulky, so I may just end the video with this model. Yeah, it's going to be, it's not really that bulky though, but alright. So next one is async IO. It's a programming paradigm that allows you to write code that performs multiple operations concurrently, that is, they run at the same time. It makes it highly suitable for IO bound tasks like network requests, file operations, etc. So with asynchronous, I allows, like I've already said, allows you to perform concurrent tasks, but the opposite of that is going to be synchronous, which waits for each operation to complete before moving on to the next. The model we're going to use, it's a built-in model, so we just need to import it. So we're just going to import async IO. Okay. So now the first thing we're going to do is define a coroutine. That is, a coroutine is an asynchronous function. So it's almost similar to a function, but there's a little catch. First, we're going to call async, and then you're now going to now do define the function the way you would any normal function, which is def, then the name of the function, and then you're now going to frame like, so let's say you have multiple actions that you want to carry out. So we'll call our first action. Maybe we want to print hello. We want to print hello world, but we don't want it to come immediately. So we want a little pause. So we'll use await. Async io dot sleep, and how many seconds we want it to sleep for. And then we'll now have our last action. So if you want to run a coroutine, the way you do this is you call async io dot run, and then the name of the function you want to run. So it will print hello, it will pause, and then it will print whatever comes after. This one at this point seems unnecessary, but just down the line, you're going to start seeing when you would want to use it. So let's say you want to create and run multiple coroutines. Let's just define a new one. So same syntax, async, def, greet, to greet people by name. So print, almost the same thing, but you just show um hello, to tender to hello, hello me again, Selena. Right. Next, now we want to now run multiple coroutine. So let's just define a main function. So usually, what did I do? So usually, if we were using like normal Python functions, you just call all the stuff individually. At this point here, you still don't really see the feature, but we'll just get into that shortly. But this one, the main idea of this is that if you had like multiple things, like all of these codes for each of the names when you call it, instead of it waiting for the other one to complete before it greets the next user, it's technically greeting each and every one of them at the same time. So await async io dot gather. Sorry, it's laziness that is doing me, and I feel like I'm just making it worse, let's just. And then we'll just run the main function instead of running the greet function. I think I'll just run main parentheses Sorry. So do you see what happened? So if it had it been we had called the greet function and we like, okay, greet Alice, oh, greet hello Alice, goodbye Alice, hello Bob, goodbye Bob. But since everything is running concurrently, so it will say, okay, run. Oh gosh, like I feel like you should understand already. The as the hello function is being called for Alice, is being called for Bob and Grace all at the same time, and likewise the bye function is being called for all of them at the same time. Do you understand? Um, if you want more details on it, you can check on my blog. But I'm just checking like some of the most important functions we would need to use. Um, Mainly, let's see handling exceptions. So let's say we just raise an error. So we just say async def what should we call it? Okay. Then we just give it a second before the function ends. So we want to raise an error. Let's just use a value error. Also don't even bother writing anything after that. Define our main function. So we'll now do our normal exception handling as you would in any Python function. So for our type, we're going to call the what's it called? The function. Then we'll now check except value error so that we can get what the error is. We want to now print out the error. And let's just run main. So yeah, it just basically functions as your normal try and accept try and you see just like the way you would call the function is a bit different. So that's why I wanted to show you that. Um Now let's visit class a bit. So we're going to run an asynchronous content manager. So it's just a special class. Do you have like you can have like a abstract user class, something similar to that. Um so let's just define our class. So this can be any single class you have in mind. Let's use that. But within it now, we're going to have special functions with certain um types of decorators. It's not decorators, you call it. I keep mixing the names. So we have our async, def. We're going to have double underscore a enter. So this is going to be the first thing that is run once the function is called. So you can just print so would know you can technically this is not what you have, depending on your function, you would know how you want to implement it. But just so we would know that this is the starting and we want to return self. Then we want a closing statement. Almost the same thing, def double underscore, not just exit, is a exit, a exit, self, execution type, um We'll just print and okay exit. So now if we are um let's define a main function where we would now access it. So I'm going to say sync with the name of our class, test, parentheses, almost, well, not exact, but almost similar to the way you'd define an object, print. Now, anything we now pass here is now going to happen in between it. So once you call run the main function, this will going to execute first. After this executes, whatever you define within here is going to be executed. And once that is done executing, this is going to be executed. So we'll just print running, I guess. Why do I feel that my laptop is listening to me? We'll just call it asyncio dot run main. Okay, I hope you're understanding. Then let's handle timeout. So you remember when we were defining functions, usually I've been using like sleep, well past like how many seconds you should sleep for. So let's say if you maybe find yourself in a system where it's like time constrained or whatever, and let's say the sleep is a little longer than you expect, but maybe like your sleep is generated by conditions instead of you just passing a direct value. Maybe the delay is like generated by certain action. So to now catch it, maybe let's say for example, okay, yes, for example, you are visiting a website and maybe the website is taking a little too long to run, then you now set like the delay is gotten from that. I'm just giving you a random example. You can set a timer that okay, once it passes a certain amount of second, it should use a message or refresh the page or something like that. So let's just find a new function. Async def task. Then we'll just give it await async io dot sleep, and let's have it sleep for like 5 seconds. Then want to just print um done. Now we'll have our main function where we're going to now handle the timeouts. So exception handling mainly would, so this is going to be a bit long. Not exactly. So would await async io dot wait for. So we're now going to call the task that we're waiting for, and then we're now going to set a timer. So we do not want it to exceed a certain amount of seconds. And if it does, that is except. So like we only want to catch the timeout error. And let's just print, let's just run main. So since what do you call it, 3 is lesser than 5 is going to pass a timeout. But had it been the time we're setting for the timeout is larger than. So after 5 seconds, the completed shit that was done is going to show because the process ran successfully. Is there another one I want us to cover? Um, yeah, yeah, you can. The rest of them will just be on my blog. So one more. This one is just a quickie. One more one I want us to cover is the python.env. If you have been coding for a while, you should be familiar with the .env, which is a file where you place like sensitive data like your API keys, your secret keys, things you don't want people, especially like for example, if you are pushing your code to GitHub, you would have your env on your server side and you just be accessing it in your code. So even in the code, even if people have access to your code, they'll not be able to see all those sensitive details like your database name, logins, all those stuffs. They wouldn't be able to see it. But when you push an update and in your GitHub, what do you call that file? Ignore your git ignore file. You will just like ignore the env file so that when you push it or when you perform it, your code will still be functioning as is while still keeping everything that needs to be secret. So to do so, we need to open our terminal. We're going to pip install python.env. Whilst that's installing, within this file, you would want to create a .env file, which is .env. So it's a text file. And within it, this way you're now going to define all the sensitive data you have, like database URL. So let me just get some demo data. So it doesn't really matter what we put here since we're not really passing it through and run anything serious. But yeah, to use this, we're going to want to import loads.env. So we're going to say from .env import load.env. We also want to import OS because we're going to use it when we want to access variables within the env file. So now to load, there are two ways. If you just load.env, it's going to automatically load any env file that is within that directory. But if you don't want to do that, we can have parentheses, and within those parentheses, you can now you do .env underscore path parentheses, and within that parentheses, you are going to now set your path to where your env file is. But since our env file is within the same directory as our python file, we'll just do load.env, and then we can now access values in it. We can say database underscore url is equals to um os dot get env, and is that what we call it here, database underscore url. And you can do that for all those other data. So if you just print, it's going to access it. So your file remains secret, your file remains private, protected, whilst your program still was as it should. So if you have any other questions, if you have any other model package you want me to cover, let me know. This video ran a little bit longer than it should be. If you want more detailed or more implementations of all these models, the link to the blog is going to be the first link in the description below. And yeah, don't forget to like, subscribe, share, and in the next video we're going to work on a project where we implement all this together. But I'll see you guys in the next video. Have a nice rest of the day. Bye guys.